Hi there and welcome. My name is Jordan. I'll be your host today for Study Hall. And welcome. Study Hall is an introductory level training for educators and students. And for this session, we are looking at sound system basics. I'm Jordan. I'll be your host. If you are joining us via Teams and you have questions on any of the material, please feel free to pop your question in the chat and I'll be able to get back to you. If you are joining us on Facebook or YouTube, you can still ask questions, but you'll have to do it through our website, and it'll have to be through email, and we will get back to you as soon as we can. So you can find our contact at resourcestage.ca. Okay, let's get into our session. Here we go. Hey, and welcome to Resource Stage Study Hall. I'm Jordan. I'll be your host for this session. And we're going to be looking at sound system basics. We're going to start with just going through some of the pieces of gear that you might find that are commonly found in sound systems. And one of the reasons why it's important to get a good handle on this is just for the ease of running events and assemblies or programs at your school. And hopefully we'll be able to keep it simple and break it down for you. If you have a question, drop it in the chat and it will make its way to me, and hopefully I'm able to provide some kind of answer. So we're going to start just by going through some of the components that are most frequently found, the most common components in a sound system. And we'll start here with microphones. They're a familiar thing. I'm assuming that many of you have seen them. I have an example of a wired and a wireless mic here. This is the same type of microphone, just in two variations. Wireless differs that it doesn't need cables. I'm sure you can figure that out by the name. I'm wearing a headset. These would be handheld mics. So mics come in different shapes, and the main difference is they're designed for different applications, different uses. So I'm hands-free, whereas if I'm holding a handheld, I'm occupied. Microphones are directional in that most microphones are directional, I should say that. And so they pick up what's in front of them, less of what's behind them. Different microphones obviously have different details on how that performs. And then next down the line would be a mixer. This is sort of the hub which all your sources, a microphone or an instrument or iPad playing music or a device, this is the hub where they all connect, and this manages all the incoming sounds, all the incoming sources. This is sort of typical for an analog mixer, this look. There are digital mixers that are more computer-based, but essentially they're doing the same thing. They just have different design, different capabilities, and different feature sets. Over my shoulder, I have a speaker. That's pretty self-explanatory. This happens to be a powered speaker, which means that it has an amplifier built into the back, and so it receives power and the audio coming from my mixer. With an unpowered or passive speaker, you would have an amplifier sending powered signal to a speaker. So this is a simple setup directly from the mixer to the speaker with no amplifier in between. One of the next most common things in a sound system is cables. Many types of cables make up most systems. And I'll go through just a few of the most common ones that you're likely to see. And I'll start with this. This is a microphone cable. I'm going to hold it up to this camera so you can see the connections. This connector is called an XLR connector, and it is the standard cable that you're going to find on most microphones, and most mixers are going to have. This mixer has these XLR jacks along the top, and I'll show you the back of this microphone. The microphone, there we go. That's the mic, and here's the cable coming in. There we go. So that's a microphone cable used for microphones. It's also used for this box, which is called a DI, a direct in box. It's going to have a microphone style connection, an XLR connection on one end, and often a 1/4 inch. We'll get to that. We'll get to what that is. So one type of connection on one side and a microphone type of connection on the other side. That's a DI box. I was talking about cables, so I'm going to go back to cables, and then we're going to come to DI boxes. I showed you a microphone cable. One of the next most common, actually before I'm jumbled, before I get too far down the line, I'm going to just mention that there are two main families of cables. One family we call unbalanced, and another family of cables we call balanced. The microphone cable happens to be a balanced cable. The difference between an unbalanced and a balanced cable is that a balanced cable is designed to better reject noise. The way the cable is made, it's better at rejecting interference or hum. Doesn't mean that it's perfectly immune to it, but it means it's better than an unbalanced cable. So a microphone cable is an example of a balanced cable. Another example of a balanced cable is this one here. This is called a TRS, a 1/4 inch TRS cable. And you can see it has two kind of little black lines. That will help us differentiate it between a TS cable, so this is a TRS, this is a balanced cable, and the connector looks exactly like this one, which is, so this one here, that one, whoop, there we go. That is a TS cable. This is a TRS, and you can see those little lines on the connector. This one has two little lines, this one only has one. That's one of the main ways how you can differentiate between these. It's quite easy to get these mixed up. They are capable of carrying the same sorts of signals, though they are not exactly the same. And let me talk more about this TS cable. The most common use for this would be for an instrument, like the plug on the back of a keyboard or the plug on a guitar that has a pickup built in. That's how you connect an instrument to a DI box, then to your mixer. That's how you get the sound out of an instrument, most likely, into a mixer. And so the TS cable is very commonly called a instrument cable because it's used for instruments. And I think I referenced it as a 1/4 inch cable. That term comes from the diameter of the plug. It's a 1/4 inch in diameter, and so it's sometimes called an instrument cable, sometimes called a 1/4 inch cable, sometimes called a patch cable. That one's pretty common. The next cable I'll show you has one end that you may recognize. I'm going to hold it up for the camera here. This is called a 1/8 jack. And again, that's a reference to the thickness of the barrel. This is the standard plug that's on one end of most pairs of headphones that are not wireless. If you have a wired pair of headphones, that's the plug that's on the one end of it. That's very common on many consumer grade like audio devices. Like that's going to be on your laptop, that sort of connection, or on a tablet. And then the last sort of connector that I'll show you are these. These are called RCA plugs, sometimes called phono plugs. And again, they are very common on a lot of audio devices. So you might see these on the back of a projector for audio out of your source or on a media playback device. So there we go. That's some of cables. Now I mentioned DI boxes. I'm going to bring this guy back out. DI box is another common piece. I showed you these views already, but there's one side, it has a microphone XLR style connector. And then on this other side, it's got, those are 1/4 inch plugs, 1/4 inch jacks. And the basic function of a DI box is to convert an instrument signal from a guitar or a keyboard or some sort of audio device into the type of signal that this mixer wants to receive, and it converts unbalanced signals to balanced signals to get an instrument cable type signal to a microphone cable type signal so that it plays nicely with a mixer. DI boxes also have some other functions. I have two other specialized ones here. This one has a headphone style cable, that 1/8 inch jack, built right into it. So this is a great device for getting audio from a computer or tablet into a sound system because it's got a microphone connection right there, an XLR connection with that 1/8 connector built right in. Another handy device, also DI. This is a Bluetooth compatible DI where it has those microphone connections to plug right into here, and then it has a Bluetooth module built in, so I can pair it with any Bluetooth-enabled audio playback device, like a tablet or phone. Then you don't need a cable. You can see it's got a pair button there, and it's got a little volume knob in it to adjust the output there. So those are really handy devices that can really help out in a pinch. You may wonder, in an audio system, why are there so many different types of cables? Like, why can't I just connect things? I've got this cable, like this one. It has different connections on each end. It's common to run into the situation where you need to get one type of connection to another type of connection, and you don't have the right cable, and you just are tempted to use an adapter. Adapters you can kind of get from a lot of these different style connections back and forth to other type of connections with adapters. Adapters are great in a pinch when you don't have access to the right cable or a DI box to get from point A to point B. But we really strongly recommend, as much as possible, trying to use the right cable for the right application. Always relying on adapters. I made a joke to some of my colleagues about it's like eating cereal with a fork. You can do it, but it's easier if you have a spoon. It just works better. And so for us, we like to say having the right cable for the right job is like having that spoon. And as much as possible, we encourage that. Adapters are a possible point of failure. It's a weak link. It's probably one of the weakest links in an audio system if you rely on them too heavily. And so to avoid those problems, we just recommend go for the right cable, go for the right DI box. So when you're making connections in an audio system, there's lots of ways of getting sound into this mixer. On my table here, I have this microphone connected with a microphone cable directly into the mixer. And now I'm going to plug, I have a cable here to plug one of my DIs in. So I've got this cable right here. It's that microphone cable. And I am going to just plug it into one of these inputs up at the top of my mixer here. It only goes in one right way. There we go. And then I'm going to take the other end and I'm going to connect it to my DI box here. And now I've got an input right here that would be appropriate for, say, a student brought in a guitar or an instrument with a pickup. There we go. So now I've got my instrument cable connected to my DI box, connected to the microphone cable, connected to my mixer. And that's how you would connect an instrument, a phone or a tablet. You could connect using this guy that we talked about already. And the Bluetooth is super handy for connecting a device, like a phone or a tablet. We've been asked a lot of questions regarding connecting devices, specifically around a laptop that's showing a presentation with a projector. If you connect a laptop to a projector with an HDMI cable, we've had many clients mention that the sound goes to the projector. Well, how do I now get the sound back into the sound system? And we recommend this little guy, the SB5. With that jack, you plug into the headphone jack of your projector to get the sound out. Oh yeah, here we go. and then connect that to your sound system with an XLR cable, and you'll be right as rain. So there we go. So now that we've kind of highlighted some ways of getting sound into the mixer, now what? Well, let's take a peek at the mixer, and I'll walk you through the general layout. And even though what you might have seen or have experience with at your school may look different, the general principle is going to be very similar. Most mixers have a very common layout. And so if we start up at the top here, there are a bunch of plugs and jacks up top for connecting sources. And I'm going to start right over here on the far left of this mixer. I've got a microphone plugged in there with a cable, and it's even labeled mic. And this input corresponds to this entire column of knobs and buttons and this fader down at the bottom. We call that a channel. So this input corresponds to everything on this strip, and so on. The next plug corresponds to everything on this strip, and the next plug, and so on and so on. And then we have a few different options for connecting directly different connections. And so the incoming signal comes in at the top. These knobs control a couple different processing and routing options in this mixer. And then it makes its way down to the fader, which is sort of like the volume control for this incoming signal. And then all of these independent volume controls across the bottom are then controlled by a master level, which controls the volume of everything. And that's the basic workflow of most mixers. That's their layout. And so to go into just a little bit more detail on what all the knobs do on an individual channel. This knob up top, on most mixers, it's going to be labeled gain. And that is a way of adjusting the level of the incoming signal. Devices and microphones all output different levels of signal. And so this is a way of ensuring the mixer has the right amount, not too much because it could distort, not too quiet because then it's not going to be, it's not going to match the rest of your signals. And so that's that first knob. The gain adjusts the incoming signal. And often on many mixers, there's a button nearby it that might, the two most common buttons would be one called pad. That's a way of lessening the incoming signal because the chances, it could happen that your gain is all the way at its lowest position and you're still getting too much. In that case, you'd press the pad button. This one does not have a pad up top, but what it does have is one called HPF, 3 letters, and it stands for high pass filter. The technical reasons why you might want to use that are probably beyond what we want to cover, but essentially what it does is it removes some parts of the sound that are not crucial. Come back to a resource stage seminar more focused on sound and mixing to learn more about that, because it's a little bit outside of our scope for today. But the next section, we have 3 knobs. This is called the EQ section. EQ stands for equalization. And what it does is essentially shapes the sound of the sound. This is like the treble and bass control on your car stereo. This is just a little bit more detailed. We have a knob labeled HF up top here, which stands for high frequency. Then we have the next knobs are paired. One is called mid, and that adjusts the mid frequency, how much more or less, by adjusting to the right for more and to the left for less. The black knob right above it adjusts the frequency that's being adjusted, so the part of the sound that's being adjusted. And then below at the bottom here, we have one called LF, and that stands for low frequency, similar to the bass knob on your stereo. And then on this mixer, we have 3 more knobs below that. The yellow one here is labeled FX. This mixer has built-in sound effects. And this yellow knob adjusts how much of this signal is going to that sound effect. Like a reverb sound or a delayed sound. You can adjust that on this mixer with that yellow knob. The next knob is labeled aux, and mixers that have auxes, an aux is a way of routing some of the sound somewhere else on the mixer. Most commonly, these would be used for stage monitors for a performer who wants to hear themselves. If I have a stage monitor connected to the aux and the performer wants to hear more of how they sound, I simply turn up the aux for that channel and they'll be able to hear themselves in those stage monitors. And then the last knob in this channel strip is called pan. And in a sound system that's configured in stereo, pan will adjust how much of the sound is coming out of the left side versus the right side. It's pretty common for basic sound systems to not be configured in stereo. And so in most cases, we're just going to leave that pan knob right in the middle. That's a great place to start and kind of set it and forget it. On this mixer, there's a couple more knobs specific, or sorry, a couple more buttons specific to this channel. Two important ones here. One has a red light, which maybe we can see a little bit on camera, but it's labeled mute. That simply turns this channel off, essentially. It's a mute button, and each one of these channels has a mute button. Right above that mute button, there's a button with a pair of headphones beside it that says listen. That is a solo feature, which allows me to connect a pair of headphones, and even if I have 10 things connected to this mixer and they're all playing at once, if I want to hear just one of them, I can put on my headphones and press that listen button, and now only that source will come out of my headphones. So if you're connecting microphones or really any sound source to a mixer, one of the first things to do would be to set your levels. And we would do that using this gain knob. And the rule of thumb for that would be, before making a connection, I want to press that mute button. Because if this channel is active or live when I'm making that connection, it can make clicks or pops or unpleasant sounds that come through your speakers. So to protect your ears and the components of your system, we're going to go ahead and mute all those channels, and we're going to make sure all of these faders down at the bottom, we're going to make sure they're all down. And specifically on this first channel, if I was connecting a microphone, I would press mute, and I would make sure my fader is all the way down. And then to set my my level, I'm going to press, then I would make my connection. I'd physically plug it in. My microphone is plugged in, so we've done that. Now I'm going to unmute, and I'm going to press the listen button. On this mixer and on most mixers, what that's going to do is that this over here on the right side of this mixer, this segmented light strip is now going to react to just to this channel on my microphone. So I'm going to grab this microphone, and I've got it right here, and I'm going to tap on it, or I'm even just going to talk in it, and I'm going to now adjust the gain level. It's important to note at this point, I'm not going to hear anything, but I'm going to see lights appear right here. And so I'm going to turn this knob up slowly while talking. Hey, and there we go. We've got some lights. And I'm going to keep adjusting the gain until I see it just, there it's turning a little bit yellow. So that's, I know I've got lots of signal. Right now I'm in the green. There's a red light up at the top. That means too much. Yellow means we're getting there, and green is good. So now I've got lots of signal. I'm all in the green. My gain is now set, and I've still not heard anything. I'm just using my eyes at this point. And now I'm going to undo that listen button, and now I can bring my fader up to the appropriate volume. Checking your levels this way ensures that we're not going to have major issues, and we're not going to have any loud booms or pops, or at least it lessens the chance of having those loud sounds, which are going to be unpleasant. So then once you've got that done for one channel, you can repeat that process for, say you've got 3 microphones and a keyboard plugged in, and you can check that for all of your sound sources. And that's how you can start building a mix. I want to talk through a couple common issues, some troubleshootings, what to do if sort of scenarios. And the first thing I want to talk through is what do you do if you're not getting any sound? Maybe we think we've got everything connected correctly, we've got everything turned on, maybe we think we do, and we've got that mic and we're expecting to hear sound and we got nothing. What do we do? Well, there's a few steps that I would take to start off, and I'll go through them here. The first step is that I would ensure that everything's powered on. That might be the assumption that, yeah, I hit the button, it's all good. I would go back and check each step. So check your mixer. Okay, I've got some lights on here, that looks good. Check your speakers. If they're powered speakers, check and ensure that your speaker's powered on. If they're passive speakers and you have separate amplifiers, check out those amplifiers. Make sure they're powered on. That would be step one. Is everything powered on? Step two would be to check all the cable connections. Maybe starting at the microphone, you might want to check and make sure that this cable connection, maybe give it a little wiggle. Just check and make sure it's secure. Check this end of the cable, and then maybe go to your mixer and check that end of the cable. And once you've checked that, if you're still not getting what you expect, I would check the connections from the mixer to the speakers and check those cables on the back of the speaker. Ensure that it's connected properly. Once you've checked all your connections, maybe check and make sure that those mute buttons on your mixer aren't accidentally pushed. So for me, it would be that one. I want to make sure it's turned off. Check all those channel mutes. Make sure you're adjusting. The next step would be to make sure you're adjusting the right channel. So my microphone happens to be connected to channel 1 on this mixer, but maybe I thought it was in channel 5, and so I've been adjusting channel 5, thinking I have channel 5. So you just want to verify each step of the way that you're actually controlling what you think you're controlling. And then the last step would be to check the incoming signal level, the input gain that we just went through. Make sure all of those steps are done in process. And chances are you're gonna find your solution. A next common problem is something called feedback. This is that unpleasant sound when a sensitive microphone starts screeching or squealing, and everyone goes like this really quickly because it gets really loud really fast. Feedback is caused when a microphone hears itself and amplifies its own signal in a loop. And gets louder and louder and louder and louder. And that's the most common cause. And we want to make sure that microphones connected to a sound system are not picking up sound from a speaker, because that's what causes it. And so if you have a microphone that's consistently feeding back, you're having problems with, the first step would be to lower the incoming signal gain. You can sort of think about that as a way of making the microphone a little bit less sensitive. It's not actually changing the microphone, but that might be a helpful way of thinking about it. So lowering the input gain would be the first step. The next recommendation I'd have is to encourage the performer to either move closer to the microphone. If they're far from the microphone, there's a greater chance of feedback. If they're closer to the microphone, then you're able to turn the microphone down a bit and lessen the chances of feedback. So either have them move closer, or perhaps just move the microphone closer to them if the performer's not able to move. And then if you're consistently getting that persistent feedback, the next step would be to maybe ask the performer if they're able to perform louder. Maybe it's a quiet singer or a quiet person speaking, and you have to have the microphone very loud. That is a greater chance of feedback. If they're able to speak up a little bit more or sing a little louder, perform a little louder, that's going to allow you to have your microphone be a bit less sensitive and lower your chances of feedback. One of the next most common things is buzzing or humming. And that's most commonly caused by a ground loop. You'll know it if you hear it. It's that unpleasant buzzing. Sometimes you'll get it from guitars or keyboards that are connected to an audio system. And one of the best ways to eliminate that is to use a DI box. I'm going to use this one as my example. Most DI boxes have a couple switches on the side. I'm going to hold this one. Oh yeah, Mark's got it there. We can see we've got some buttons here. This top one has the word ground written beside it. The most common culprit for humming and buzzing is a ground loop. And if you're using a DI, pressing that ground loop button, turning it on, will eliminate it. That's part of the design and function of a DI box. And so if you're not using a DI and you've got a hum, the first step would be to try using a DI and pressing that ground button and eliminating the hum. Some instruments in particular, like electric guitars or acoustic guitars or bass guitars that have pickups in them, can be particularly noisy. A DI box might not fix those issues, but that's kind of your best bet for fixing or curing a buzz or a hum. Next would be volume problems. We have too much sound, or maybe not quite enough sound. How do we get kids on stage, a kids choir, how do we get them to be louder? Not enough sound. The first step I would do is, if they're using microphones, if they're not using microphones, I would say use a microphone. And then if they're still not loud enough, I would reposition the microphones so they're closer to the performer, or reposition the performers to be closer to the microphones, and encourage louder singing. If still not working, then it might be the sort of microphone you're using. Maybe there's a better microphone for that application. And if you have that question and you're not sure who to ask, you can ask us and we can make a recommendation. What do I do if the speakers are too quiet? I've got everything maxed on my soundboard. I've got all the levels maxed. I've got this all the way up. I've got these all the way up. And I'm still not getting enough sound. If that's the case, consider your speaker. If I was using this speaker, because it has an amplifier built in, I would go to the knob that controls the amplifier and turn it up a little bit. That's a way of getting more power out of your speaker. If you have a separate amplifier, you could do the same thing. It's just not going to be located on the back of your speaker. If you have active or passive, go to your amps and try turning them up. If you've tried all of those, so you've made the adjustments on your soundboard, you've turned up your amplifiers, you've turned up your speakers, if that's still not solving your problem, it may be the case that you need a more powerful or more capable speaker, in which case we're happy to help. We can make a recommendation. A third problem is sound that might be crackly or distorted. This can often be caused by clipping. Clipping is what happens when a mixer or a speaker or a sound device is receiving too much sound. So say I had this microphone and I turned my input gain all the way up, I turned my fader all the way up, and I yell into the microphone. These systems are designed with maximum kind of limits, and if I go beyond it, it's going to distort. It's going to make an unpleasant sound. And so if you're getting that distorted or clipped sound, it means you've got too much happening somewhere. And you can solve these by looking for red lights that are indicating on your mixer. Often, if something's clipping, if there's a green light, that green light's going to turn red and it's going to show you. And you can solve it by lowering the input gains or lowering the levels of your channels, lowering the faders, and bringing everything back towards what they were designed to handle. Overdriving a system, getting that distorted sound consistently is not the greatest. You can do damage to some of your devices, particularly if speakers are being overdriven consistently. They're not designed to handle that, and they could damage as a result. So do your best to kind of rein that in and listen for those sounds. So that's our basic walkthrough. We've covered the devices that make up a sound system. We've talked a bit about how to connect those devices together to a mixer. We talked about cables and DI boxes and a little bit of troubleshooting. If I've mentioned something that you're curious about and you have a question that I didn't answer, feel free to email us. You can reach us at resourcestage.ca. Study Hall is the page there where you can ask your questions or you can check out future seminars. You can also visit horizonsolutions.net. That's our main company website. If you have a question about a product or a rental, you can reach us there and we're happy to hear your questions. All right, there we have it. Thank you for joining us. Just as a reminder, Study Hall exists as part of Resource Stage, which is all about training and equipping folks with the tools to grow in their knowledge of audio, video, production, and lighting. This is our final event for the season, but we will pick back up again in the fall with our free monthly training seminars through Resource Stage. And if you'd like to know more about Resource Stage, you can visit our website at resourcestage.ca. You can find past seminars, links to our YouTube page where all of those live. You can also find information about upcoming seminars and events. And if you have questions, you can reach us through our website there. You can, as I mentioned in that last video, you can also visit our main website, horizonsolutions.net, to find out all things about audio, video, lighting, design, install, rentals. Yeah, feel free to check us out there. And thank you for joining.